Hi, welcome to our Semester 2 Capstone video. In this video, Danny Gleason and I will analyze the motion of a bow and arrow. What units will this project be related to? This project is strongly connected to Unit 6, which is 2D motion, and Unit 7, which is energy. What exactly will we analyze? Danny and I will look at how energy is stored at different points in our bow and arrow system, as well as the velocity throughout the entire motion. If Danny and I actually wanted to analyze the motion of a bow and arrow, we would need to first get a bow and arrow. The only person who we knew with the supplies was Jax Valenti, so it would be a good idea to kidnap him and steal all of his materials. After Danny and I made fun of Jax's poor sense of style, he cried for hours and we were able to kidnap him. We made up a game plan and decided to shoot the bow 3 ways. One way would have the bow pointing downwards, one way would have the bow pointing almost completely horizontal and traveling at a very fast speed, and the final way would have the bow also pointed almost completely horizontal but at a smaller speed than trial 2. Unfortunately, we ran into a problem when Danny said that he was not available on the day of filming. He said that he had bad allergies and he was not feeling well, so I sent a doctor to take care of him. We'd have to find a new archer. Me personally, I could not step up to the role of being an archer. I cannot hit anything for the life of me.
He almost had yeah, right about there. Pull it back hard and don't miss my garage. Yeah.
So I decided to put Jax to use. Jax was not involved in the making of this capstone. The only role he had was shooting the bow and arrow. You can go. We decided to name the system as the Earth, the bow, the arrow, the string, and the target. For the first motion, before the bow is pulled, there is no energy in the system. However, once Jax uses some of his ATP chemical energy, he's able to put some elastic energy into the system by pulling the string back. When we observe the arrow while it's in its motion, we can see that there's a large amount of kinetic energy in the system, because the arrow is currently moving. There is still some gravitational energy in the system, as the arrow is above the point of reference, which is the ground. Then, when the arrow finally lands on the target, most of the energy is converted into elastic energy. The idea is that the foam inside the block is holding the arrow in. Since the foam block is a little bit above the ground, there is still some gravitational energy in the system. Now when we switch over to looking at the velocity, you can see that the horizontal velocity is constant. This is because all the air friction is negligible. The vertical velocity, however, has a negative y-intercept. This is because since the bow is pointed downwards, the arrow would have some starting velocity in the negative vertical direction.
Oh, I'm gonna share the pad with my iPad.
We decided to do our energy flow diagram a little bit different for this one. We included Jackson in the system at the beginning, so his chemical energy is graphed in position 1. Position 2 and position 3 are largely the same as the first trial, but in position 4, we decided to not include the target in the system, so there is energy leaving the system via work when it hits the target. We can see that this arrow has the greatest horizontal velocity out of all the trials. This is because Jax is holding the bow near horizontal, and he has the string pulled back very far. The vertical velocity is the smallest out of all the trials. This is because since Jax is fighting the arrow so fast horizontally, the arrow does not have a lot of time to accelerate towards the ground due to gravitational acceleration. We decide to sort this energy flow diagram much like the first trials. However, for this one, position C is different because we have the bow higher above the ground, so you can see that the kinetic and gravitational energy are balanced. Also, in this motion, the arrow hits the ground, it does not hit the target, therefore all the energy is transferred into thermal when the arrow hits the ground. The horizontal velocity is probably about the same as the first trials, f not lower. The vertical velocity, since Jax is standing up and the arrow is fired very slowly in the horizontal direction, is probably the greatest in this motion. To wrap the video up, I just want to give some closing thoughts. Remember, no energy leaves or enters any system without working. All energy is conserved and follows the law of conservation. When an object hits the earth, energy is transferred thermally, and Jax Valenti is a person who has actual use and purpose in the world.